Lunokhod 1 was the world's first remote-controlled planetary rover to operate successfully on the surface of another celestial body. From November 17, 1970, until September 14, 1971, this Soviet marvel explored the Moon's surface in what became a pioneering chapter in space history. But on September 30, 1971, after nearly a year of successful operations, the rover suddenly failed to respond during a scheduled communication session. Multiple attempts to re-establish contact failed. Then on October 4, 1971, the Soviet Union officially declared the end of the Lunokhod 1 program. And for decades, that was the end of the story. Or so it seemed. Over 40 years later, American scientists managed to target the Soviet rover's retroreflector with a laser beam. And what happened next shocked them. They received an incredibly strong return signal, a reflection so precise and intense that it defied all expectations. The signal was so clean, it almost looked as though someone had polished the reflector and turned it to face Earth. Since then, this forgotten piece of Soviet engineering has become an unexpected asset in modern American experiments. Today, researchers use Lunokhod 1 for high-precision scientific measurements. Officially, they say the goal is to verify aspects of Einstein's theory of relativity. But more on that later. Let's go back to 1970. At that time, the United States had just pulled off one of the most spectacular feats in human history, the Apollo 11 moon landing in July 1969. The Soviet Union had suffered a bitter defeat in the space race's most symbolic prize, landing a human on the moon. But they weren't ready to give up just yet. Instead, they turned to uncrewed exploration, focusing on robotic vehicles and sample return missions. Lunokhod 1 was not a consolation prize. It was a different kind of ambition. One that didn't risk cosmonauts, but still pushed the boundaries of science and engineering. What many don't know is that Lunokhod was originally designed to support a manned lunar landing. The idea was to send rovers ahead of cosmonauts, who would then use them for mobility, scouting, or even rescue missions in case of emergencies. When the Soviet crewed lunar program stalled, Lunokhod was repurposed into a standalone scientific platform. In a way, it became the USSR's answer to Apollo, but robotic. The rover was developed at the Lavakine Scientific Production Association, and construction was led by chief designer Georgy Babikin. Lunokhod 1 was truly a marvel of its time. It measured 2.3 meters long, 1.5 meters wide, and stood about 1.35 meters tall. It had a tub-shaped aluminum body on 8 wheels, and its top was covered with a dish-like lid, which was actually a large solar panel that also protected the instruments during lunar night. The rover weighed just under 800 kilograms and carried several scientific instruments, including an X-ray spectrometer, a cosmic ray detector, 2 television cameras, a laser retroreflector. Each wheel had its own motor and suspension system. The rover could climb slopes up to 20 degrees, and its ground clearance was adjustable. Before being cleared for launch, the rover underwent intensive testing in Soviet laboratories. It was placed in vacuum chambers, thermal simulators, and rolled through fake lunar soil to assess traction and durability. Operators even practiced flipping the rover back upright remotely, using controlled shifts in wheel torque. Nothing was left to chance. On November 10, 1970, the Luna 17 spacecraft carried the rover into space. After entering lunar orbit on November 15th, it began a fully automated landing sequence. Touchdown occurred on November 17th in the Sea of Rains. And even that name, Mariam, evokes the lonely beauty of this remote landing site. First steps on the Moon. Once the spacecraft confirmed a safe landing, it deployed ramps. Then, very slowly, the Lunokhod descended. A Soviet technician watching the grainy black and white camera feed later described it as watching a beetle crawl across a chalkboard on another world. The team held their breath. If a wheel slipped, if the surface crumbled, the rover could fall and be lost forever. But Lunokhod 1 rolled off without issue. It was the first vehicle ever driven on the surface of another world. The Moon is much more dangerous than it appears. What looks like smooth terrain is often covered in fine dust called regolith, which can hide sinkholes, rocks, or sharp slopes. And every mistake was potentially fatal. Unlike modern rovers like NASA's Perseverance, which use autonomous navigation, Lunokhod 1 had no onboard intelligence. Every move had to be manually commanded. With a 5-second radio delay, operators used camera snapshots to steer it. One engineer described it as driving while looking through a dirty keyhole 5 seconds in the past. To reduce risk, operators rehearsed every maneuver back on Earth using a full-scale mock-up moon field. Each shift required 5 to 6 people: a driver, navigator, commander, antenna specialist, and science officer. They rotated in shifts, working around the clock. Lunokhod 1's scientific legacy was impressive. During its mission, the rover traveled 10.5 kilometers, conducted 500 soil tests, and sent back over 25,000 images. It survived 3 lunar nights, each over 2 weeks long. And its wheels left faint but permanent tracks, still visible from orbit today. And yes, those tracks were key in helping NASA locate it 4 decades later. Rediscovery and the laser experiments. After contact was lost in 1971, Lunokhod 1's exact position was unknown. When NASA's Lunar Reconnaissance Orbiter began photographing the moon in high resolution, scientists hoped to find the missing rover. In March 2010, they did. Not only was Lunokhod 1 intact, it was standing upright, with its tracks curling away like frozen memories. Tom Murphy's team at Apache Point Observatory wasted no time. Using a 3.5-meter telescope, they fired laser pulses toward the moon. On April 22, they received a powerful bounce signal, confirming that the retroreflector still worked perfectly. This wasn't a lucky shot. Because of its location and angle, Lunokhod 1 reflects laser light better than any other reflector on the moon, even the ones left by Apollo astronauts. Since then, scientists use it for lunar ranging, precise distance measurements that can test theories of gravity, space-time, and even dark energy. It has become an invaluable tool in modern physics. Science is more opportunistic than you'd expect. It's ironic the Soviet Union spent millions to build Lunokhod for Soviet Cold War prestige. Yet decades later, its greatest contribution is to American-led scientific research. And it's still up there, silent, motionless, but reflecting light from Earth like a cosmic mirror. And one final surprise. In 1993, Lunokhod 2, the second Soviet rover, was sold at a Sotheby's auction in New York. It was purchased by Richard Garriott, a video game developer and son of an American astronaut. He paid just $68,500. And yes, he now technically owns property on the moon. So the next time someone asks who was the first to drive on the moon, you can proudly say it wasn't NASA. It was Lunokhod, Soviet, solar-powered, and still reflecting light 50 years later. Please don't forget to subscribe or write a comment and put a bell so as not to miss new videos. Thanks for watching.